Well, good afternoon. I want to welcome everyone here today. Thank you for taking your time out of your schedule to visit with us. We're here to share with you what I think is actually a rather exciting activity that's going on in partnership between Huawei and Xilinx. Giles is here from France. I'm representing the folks in Shenzhen. I work for Huawei here in the United States. But I can tell you the folks in Shenzhen are very motivated, very interested in what we're about to share with you this afternoon. Giles, do you want to say a few words?
Yeah, so first of all, I'm Gilles. You know the French pronunciation, but that's okay for me. So I'm Gilles. I'm the director of the Huawei communication. So we are trying to make this working with Chuck on the Gilles, but this is coming back. Okay. So I'm in charge of the marketing for the Huawei communication at Xilinx, and we are, as Chuck said, very excited to be here today and to present jointly this activity.
Yeah. Okay. A few words about our respective companies. Huawei is a leading global communications company. Also, it is evolving its skills and technologies in the IT space as well, because it sees those as two very complementary areas going forward. There is significant convergence in these technologies, and actually this leads into some of the discussions that we'll have this afternoon. Huawei, basically, to quickly put the company into perspective, and I know we don't spend a lot of time on this chart, is approximately a $40 billion company. It spends about 15% of its revenue stream in its R&D. It's very R&D focused. And it pursues three major market areas. I would say about 2/3 of its revenue comes from its communication infrastructure area, about 20 to 25% from consumer products, and a small but rapidly increasing enterprise business sector that takes focuses on integrating these various technologies. Giles.
Thank you, Chuck. So from a Xilinx perspective, Xilinx is the leader on the FPGA world, around 2 to 2.3 billion company. We have a very successful portfolio, and combined with our new software suite called Vivado, we are providing and we are enabling customers in different market space, from the communication that we are here to talk today, to the aerospace and defense, automotive, consumer, and other markets as well. And what we'll present today will show the leadership technology that we have, from not only logic IC, high-speed SerDes, but as well from a software development that are helping customers to improve their productivity and efficiency.
Okay, so what is the background to the discussion that we want to have with you today? And basically, it's the evolution of what we refer to as the 400 gigabit Ethernet technology. And the why is this becoming so important? And I think you can see from the chart what the projections are for the data and bandwidth requirements of the future, especially as you move out through the end of the decade. The data rates that need to be supported. You can ask, well, what's driving all of this? And you step back and you look at the projections that are out there. And I think they're projections that are very realistic. By the time you get to the end of this decade, there's an expectation that connected at various points globally across the internet, you're going to have approximately 50 billion devices, intelligent devices, predictive devices, connected to the Ethernet by 2020. It's also expected you'll probably have upwards of 300 billion passive devices connected to the internet, all supporting approximately 7 billion people. This is going to drive significant data requirements, data needs, data traffic. So we're all very comfortable that these trends that we project on this chart are going to come to fruition, and this is going to evolve and require the technologies in the backbone that support this kind of data transmission. Giles.
Perfect, Chuck. And just to add some things, why 400 gig Ethernet to start with? First of all, we believe that this is the market that will first emerge, requiring this type of application and bandwidth. And on top of that, imagine all of us I'm coming from France, sorry with my accent, but that's the way it is. But we have also people coming from all over the world, and we are still being connected to where we reside. We have still all our phones, PCs, and whatever it is, the Slimbox and others, that are all over the world connected. And this what will drive, in the next decade, all the need that we have to drive the 400 gig. Adding the data center to data center, and all those machine to machines. And you are suddenly imagining the amount and massive amount of data that will have to be transported, and why then we will need to have the core infrastructure evolving to those type of infrastructure.
So what are the challenges going forward? Well, one of the things that Huawei's been addressing with the help of Xilinx is basically doing the research and prototyping for its core routers to drive and to show that this level of capability and throughput is feasible. We can support the bandwidth, the 400 gigabit optical bandwidth. We can do this with managing very efficiently power requirements, leveraging an environment of scalable clusters, and leveraging the advances in memory technology and smart memory technologies, and proving that within, in this case, the line card that goes into the router, that we can support the logic and throughput for this level of capability.
So when we started discussing with Huawei about those challenges, we look at our technology and we look at what the ecosystem that we have already in place. And so, as you are seeing in the card, in the slide, Huawei was looking for high-density CFP2 connectivity, that we are uniquely positioned with the technology that we have to connect 4 CFP2s into a single chip. And we are looking for efficient and power-efficient ICs as well. And so that's the way we started to engage with Huawei, saying, how can we help you to address those challenges, and then move into the development of the line card. So let's talk a minute about the line card. And so this is the Huawei line card. And so, as you can see, we are using 2 Virtex 7 FPGA. So high-end device, Virtex 7 870T, heterogeneous 3D IC chips with 16 28 gig SerDes in it. And this diagram is coming directly from the Huawei Shenzhen team. And that was the key parameters that allowed them to select this unique 400 gig chipset into the market, being able to deliver with 16 28 gig SerDes, being compliant with the VSR, very short reach standard, having power efficiencies, and having then the tools associated, our Vivado design suite, that help, and Chuck, you can probably jump into it, that help Huawei to achieve the design.
Yes, actually, Huawei, when Huawei went forward to look at developing the prototype, it looked out in terms of where can we find a partner that can provide us the level of programmability and integration. And our conclusion was the best solution in the marketplace came from Xilinx. And as we go through this presentation, one of the points is that this is an area that we plan to continue to work with Xilinx and even drive to higher levels of integration and efficiency going forward.
So thank you, Chuck. Let me add a couple of points around the complexity of those line cards. The goal of Xilinx partnering with Huawei is really to try to abstract as much as possible and help Huawei to abstract the complexity of the design. And so with the Vivado tool suite, we are uniquely positioned to help on this integration with very efficient place and route, very efficient IP core technology and smart core library that could be used as well to complement the design. And so that was a key. The efficiency was critical for Huawei to select also Xilinx in order to be able to match those complex design into a single line card. So when we're talking about critical enabling technology, what do we mean? We mean that being able to have the capabilities to fit all of these, all the requirements that Huawei is looking for, and all the criteria that Huawei was looking for from a power consumption, from the number of SerDes, from the speed, from the bandwidth capabilities into a single chip. And so when Huawei selected the 870T, so the technology from Xilinx, they were looking for this leader chip technology that we have. From a 3D IC perspective, we are the only 3D IC 400 gig chip into the market. We are using TSMC as our preferred and 28 nanometer, and 20 nanometer, and 16 nanometer foundry. We have co-developed with TSMC the 28 nanometer HPL process. HPL stands from high performance, low power. So co-developed and optimized for FPGA by TSMC and Xilinx. So that was those critical items on the ecosystem of Xilinx and the chip technology that we have that also reassure Huawei that they were selecting the right partner.
Yeah. So what is it that we want to show and share with you? This is a picture of the Huawei's core router. We have been able to validate the 400 gig processing capabilities of the router. We've been able to address the packet sizes that you see on the chart. We've been able to validate that there is no packet loss at any packet size. We can also, we've learned so far is the being able to develop the bus architectures, high-speed bus architectures. We can utilize these Xilinx chips, and we can achieve the high integration and utilization on the cards within the router. So from a Huawei perspective, this has been a very successful collaborative prototype development exercise. It's activity. One of the things that we're looking at is to show that the router has the capability to support the 400 gig throughput. We know that the work that's ongoing in terms of standards development within the IEEE is looking to have the standards developed or completed by the 2016 timeframe. When the 2016 timeframe arrives, we want to be prepared and the marketplace aware that we have the capability to support that standard. The interfaces have been built into that standard, and we are ready to move forward in taking it into the marketplace. We're also looking at using this lead time we have to further develop, as Giles said, the integration, the throughput, the power efficiencies built into the core router system, and to have a even more effective and productive solution when that time frame comes that we can take the IEEE standard to market. In fact, here's a chart that looks at the roadmap for the IEEE. Last year, the 400 gig activity initiated its study group phase. As it goes into the standards development phase, the projection is by 2016, it'll be ready for implementation in the marketplace, and we will, during that period, we will continue to be able to show through our joint activities and improved integration the capabilities that we'll have in place to support that standard. It's very important that Xilinx and Huawei intend to remain very close and cooperative partners, and to ensure that as we move into the future, and Giles will talk to the single chip integration, that we'll be able to move that into the prototype as well.
Thank you, Chuck. So let's talk for a minute about where the technology is moving from where we are today. So as you have seen, the line card is today ready to go, implementing the Vertex 7 28 nanometer technology, but we are not stopping there. We are already shipping today our new 28 nanometer technology and portfolio. It's live today in our booth. We are shipping it since December to our customers. And soon we will get our high-end chip that will allow this line card to evolve from a two-chip solution to a single chip solution. Meaning 400 gig using IPs and technology from Huawei into Xilinx chip, single chip solution. What does that mean? That means that power saving, complexity of the board reduction, optimization of the software, and much less density that adding potentially a second chip to go beyond the 400 gig. So again, everything, it's not PowerPoint. We have the 20 nanometer ready, and we are demonstrating it already into our booth. That's the first chip. We are rolling out this year additional chip. This single 400 gig chipset will be available later on in the year, earlier on next year, and will allow and will continue working with Huawei to do this next level of integration. Not only from a technology perspective, but from a tool suite perspective, because then that will add additional challenges, and being able to fit and to fill up to more than 90% those new chipsets will allow Huawei to even go beyond what we're looking for.
So what does that mean, and what's it mean today, and where do we plan to go for the future? I'll share with you that both from a research perspective and a market development perspective, Huawei is quite excited about this. It's a solution that has actually been delivered 2 years in advance of the plans for the technology going to the marketplace. We plan to use these 2 years to further improve the efficiency and the capabilities of the prototype and to have the products ready. But most importantly, we've demonstrated today through this partnership that the feasibility of employing 400 gig in the logic layer. So this is an important milestone, and a milestone that will be built upon over the next 2 years. You want to say a few words?
Yeah, and so again, as we are seeing on the slide, the companies want to continue working together. We have already lined up the roadmap of our 20 nanometer technology that will allow Huawei to even do more integration, and so be even more competitive into the market using our leadership technology. So, but what the other portion of it is, we are all, both Huawei and us, committed to the standards. Of course, we need to be ahead of the standard as well to allow companies like Huawei working with us to demonstrate pre-standard implementation. But both companies are also committed to drive the standards, and as soon as standards will be compliant, then to be able also to deliver fully standard solutions.
Very good. And I think that's the other point. In addition to continuing to work on the prototype and drive the capabilities of the prototype, Huawei remains very involved in the standardization development activities around the 400G activities. We plan to be very involved in those activities and ensure that not only that we're providing what we've learned from the prototype and the activities in the lab to the standards development, and we're ready to utilize those standards when they come to fruition.
So thank you, Chuck, and again, thank you very much to have been with me on the stage.
Thank you.
Thank you.